Okay, so here we have an example of a video with static forces, where we have a small mass that has a mass of 1.8 kilograms, suspended by two different cables, one attached to like the wall, and it has a tension of T1, another cable attached to like the ceiling, where it makes an angle of 30 degrees with the horizontal or the vertical, as shown above, and we're tasked with finding the tension in both of those cords, T1 and T2. Obviously, the situation here is that the mass is being held in one location. First thing we want to do is draw a free body diagram. So we have weight of the mass, we have tension 1, and we have tension 2, or in this case, that's at 30 degrees or that's at 60 degrees. So now when we want to try and solve this problem, we want to look at, first of all the forces in the x direction. So the sum of forces in the x, and they should be equal to 0 because the object is being held in one location. Then we want to look at what are those forces. So obviously we have T1 going to the right, and we're going to minus from that any forces or components that are acting in the other direction. Here we can see that we have a component of tension 2 that is going in the x direction, and we can calculate that several different ways, but from this original diagram, this component of T2x should be equal to T2 times the sine of 30 degrees. And so when we look at that and solve that, we get T1 equals T2 sine of 30. So now that's all we can do with the x motion, the x direction. So we're going to look now is at what happens when we look at the information for the y direction. So the sum of forces in the y should also be equal to 0 because the object's not falling to the ground or accelerating up. And those forces based on my free body diagram or my diagram include the weight of the object going down minus any forces that are acting in the upward direction. And the upward direction should be some y component of T2. And that component of T2 can be calculated as T2, obviously it's looking at this component, which is adjacent to that 30-degree angle. So that is going to be T2 cosine of 30. Now from this, we know that weight is equal to mg. So we get mg equals T2 cosine of 30, or from that standpoint, mg over cosine of 30 should equal T2. Now the weight, in this case, is going to be 1.8 times 9.8, which is 17.64 over cosine of 30, and that gives me a value then of 20.3 newtons for T2. Once I have that value, I can simply substitute it back in here to find T1. So T1 should be equal to 20.3 times sine of 30, which is a half. So we should get like 10.15 newtons equal to T1. That's an example of how you use both the X and Y Newton's law statements in order to find by substitution the two tensions that are involved.